everybody. My name is Joe Coco, and I lead the product and program management team for Windows IoT and for some microservice platforms that sit on top of Windows IoT. Welcome to the build session on the Windows IoT roadmap. I'm excited to have you here. We'll talk about Windows IoT. I'll give you an overview of where it fits into the intelligent edge landscape. We'll talk about cloud connectivity, some new features that are available, and I'll also highlight some other build sessions that go deeper into some of the topics that I'm going to be covering today. So with that, let's jump in. So as I mentioned, today's topic is the Windows IoT roadmap. And our agenda, we'll talk about first where Windows IoT fits into the edge landscape, recent product enhancements, and some upcoming features that are in preview. Now, I first want to start by putting Windows IoT into context in terms of where it fits in the cloud to edge spectrum. Now, if we zoom in a little bit first, so the top half of this diagram is the cloud. The bottom half is the edge. But if we zoom into the edge here for a moment and focus on this, you can see in this diagram, this continuum, as you go from left to right. So on the left-hand side of the diagram is the OT edge, or the operational technology edge. These are the types of devices that people often refer to as embedded devices or IoT devices. They're typically fixed-purpose devices, meaning they do one task. For instance, defect detection on a manufacturing line, or when you pay for parking at a parking garage, when the parking meter thing that you put your credit card into is a fixed purpose scenario, right? That's all it does. Even an MRI machine, it's for MRI imaging. And going further to the right, you have your IT edge, or your enterprise class devices. And these are typically multi-purpose devices, meaning they run multiple different independent workloads. Those workloads may change over time. And as you go from left to right, devices start smaller and less expensive and become more powerful as you move to the right, and the most powerful on the far right. And so starting on the far left, we have these devices that we refer to as the tiny edge. These are microcontroller class devices. They typically run an RTOS or a kind of a custom embedded Linux solution. This is your sensors and actuators. It could be cameras, it could be temperature sensors, vibration sensors, all kinds of environmental sensors. And these are the least expensive, typically small, but not always small devices. We have a couple of offerings here. Azure Sphere and Azure RTOS are some examples of that. As you move to the right, to this light edge bucket, these tiny edge devices connect often to the light edge devices. That's the most common scenario. So the light edge is represented by these MPU or microprocessor class devices. The same type of hardware you might have in your laptop. These devices that run Windows IoT Enterprise typically cost $200 to $2,000 US. They're often embedded as a brain in a more expensive device. So it could be the brain of a pet food manufacturing device, for example, or an MRI machine. And I give some examples here below of where Windows IoT is used today in these kinds of devices. So industrial HMIs, a lot of industrial equipment runs Windows IoT, but medical equipment, gateways, of course, of all types, robots, kiosks, digital signs. I'm sure you see a lot of these kiosks and digital signs in airports and retail, fast food restaurants. And there's a lot of manufacturing equipment. There's a lot of energy and oil equipment, drilling, gas and oil, electrical power plants, et cetera. Lots, I'm just kind of covering a broad swath, but there's many more devices that I could list, and many that you've probably seen yourself. Also in this light edge category are these server class devices, but these are small servers. These are small embedded servers typically. So these are things that are, for example, on the manufacturing line. They're in the physical world, just like the tiny edge and the other light edge devices. They're not in a on-prem data center typically, or in a kind of an IT closet. And so they're often smaller servers, and we have an offering here called Windows Server IoT. So both Windows IoT Enterprise and Windows Server IoT, that represents the kind of Windows IoT family today, and it targets this light edge category of devices. Now, going further to the right, you have your heavy edge devices. These are your more powerful servers, hyper-converged infrastructure. These are the things that are in the on-prem data center or the IT closets most often. And we have offerings here in the Azure Stack family. Azure Stack HCI, Azure Stack Edge are examples of this. Now, one thing that we're seeing happening is, you typically had your IT administrators and your OT administrators were separate people using separate tools with separate requirements. And increasingly that's merging. So, part of the reason that's happening is as more of these OT edge devices, these embedded devices connect to the cloud and connect to the internet to the cloud, the security becomes more important of these devices. The way they're managed becomes more important. And so the IT folks, are taking more of an interest in these kinds of devices because they're on the network, and they need to be managed appropriately and secured appropriately. So these groups of people and the tools they use and the security requirements are starting to come together more. And we'll touch on security in this discussion. So that's where Windows IoT fits into this spectrum of kind of the tiny, the light, and the heavy edge. So with that, I want to touch on some of the trends we're seeing in the industry. Right now, we're seeing a push to connect more of these devices. Now, maybe not directly to the cloud, maybe through a gateway, but nevertheless, they're connected. The data they're generating gets up to the cloud. Often they're connecting directly, but there's a complex network topology here at play. But as they get connected, it's really about connecting the individual asset, the individual MRI machine, or the individual fuel pump, or the individual robot. But what we're also starting to see happen a little bit, it's a slightly newer trend, is where entire environments like a factory are getting connected, right? And that becoming more intelligent as a result. So bringing more AI workloads down to the factory. And then beyond that, we're seeing a push towards more autonomous solutions. And this is really being driven by the labor shortage, the supply chain shortage, the cost of wages, all these things that are driving more automation. Primarily worker shortage is really a key driver here. So, you see this all around you, on a regular basis, the fact that you can order your own food at a fast food restaurant by interacting with a kiosk, or printing your own bag tags at the airport to put on your luggage, are some examples of more autonomous things that are happening. But it's much broader than that. There's a lot happening in factories and other kinds of settings, even entire cities. They're becoming more autonomous, where different inputs and different devices are being used to more efficiently manage a city. That could be traffic across the city. It could be wastewater runoff. So you're really creating these intelligent ecosystems that are more autonomous. Now, as we think about these trends, some of the things that we're doing in Windows IoT, both recently and upcoming, really are intended to address these trends. So the first thing we're doing is simplifying the ability to integrate with Azure, to use the Azure cloud from Windows IoT devices. I will touch on what that looks like in this discussion today. I mentioned that security becomes more important as these devices are no longer islands and that are disconnected, but get connected either directly or indirectly through a gateway. And so security becomes paramount. So as a company, we're investing billions of dollars in security across our entire Windows platform, which Windows IoT benefits from. We're also enabling Linux-based AI workloads. So there's a lot of AI that was developed in universities that's been put into Linux containers. And our Windows IoT customers want to take advantage of that without having to go buy another device, another Linux device to run those. They want to be able to run them on their Windows device. And so we'll talk about that. And then the next two bullets here are really related. It's supporting microservices that are delivered from the cloud to the edge and enabling cloud-native programming models and container orchestration solutions, such as Kubernetes. So there was a lot done in the cloud to create these microservices and to use Kubernetes and Azure Arc to manage all of these resources. That is migrated from the cloud to the heavy edge fairly recently. So to Azure Stack HCI is an AKS HCI, Azure Kubernetes Service AKS HCI are good examples of that. But we're now taking these solutions, containers, Docker containers, Kubernetes, Arc, down to smaller and smaller devices. And we'll touch on that as well today. Also something that we're seeing directly come from our customers asking us to do this. So I just want to touch on a few things that we've done recently. So the first one I talked about making it easier to connect to Azure from Windows IoT devices. Last summer, we launched what we call Azure Edge for Linux on Windows, or EFLOW, which allows you to do two things: run those Linux containers on your Windows device, but also it automatically connects to Azure IoT. In addition to that, again, the fact that security becomes more important as you connect. So we brought a number of security and lockdown features to Windows IoT, so you can really lock down that experience and have the security you need. In the middle section here, it's really about lowering the BOM cost. As automation becomes more common, you need more devices. And if you're a large multinational manufacturing company or a large retailer with thousands of locations, or you may need thousands of devices. So cost becomes important as you're deploying thousands or even tens of thousands of devices. So we're bringing in lower cost ARM64 silicon, and we've also reducing the OS footprint. We'll touch on those briefly. And then finally, on the right side, more device management capabilities to control the rollout of updates and security fixes, and to ensure that the image that's on the device is what is expected to be on the device, what has been certified. Now, let me go a little bit deeper into EFLOW. I mentioned this earlier, and really what EFLOW is, it does two things. It makes it easy to connect to Azure IoT Edge and run Linux Edge modules on a Windows device. And specifically what it is, it's on the right-hand side of this slide, you see this diagram. It's a Windows device. The left hand shows the Windows host operating systems and Windows applications running. The right side shows what we call the Mariner Linux VM. Mariner is a name for a Microsoft Linux offering that we're using here as a VM running on Windows. And this is a lightweight VM designed for production devices, production deployments. And it has in it, the VM has in it Azure IoT Edge. And it also allows developers to deploy their own modules into that VM, running side by side with the Windows app at the same time, and with interop between the Windows apps in these Linux containers or Linux workloads in the Mariner Linux VM. If you haven't tried it yet, I encourage you to do so. It runs on Windows Pro, Windows Enterprise, of course, Windows IoT Enterprise, Server. So you can try it on your own developer box if you want. And I included a link here. You can go read more about it and get the bits and give it a try. We don't charge anything for getting the bits. It's free. You will need an Azure IoT Edge account. But other than that, it's easy to get up and running and trying it out. And once you do, now you have access to a bunch of Microsoft first-party Linux modules from our marketplace, like I've listed here. PC Publisher is a common manufacturing protocol so that you can leverage. Cognitive services, some of our AI capabilities, anomaly detector, SQL Edge, etc. There's a bunch of modules that you can take advantage of from the Azure marketplace. But as a developer, you can also create your own modules, Linux code that you can then put in your container registry and have pulled down to the Windows device into that EFLOW VM. And I do want to emphasize it's a very small, lightweight VM. So the intention is for this thing to run on small devices, and it's an entirely curated solution from Microsoft. So we, going back to the previous diagram, we keep everything secured and up to date. So of course, the Windows OS is secured and up to date with the latest security and critical fixes, but also the Mariner Linux VM is kept up to date, as is the Azure IoT Edge runtime that's in that VM. So it's a fully managed solution from Microsoft. I do want to touch on security a bit. This is a very dense slide, so I'm not going to go through all of it. But I mentioned a few times that security becomes more important, and I wanted to give you a sense of the kinds of things we're doing here at Microsoft to secure the Windows platform. And it really starts at the bottom with a bunch of processes and programs to really ensure the ecosystem itself is helping to contribute to a more secure environment. And so things like securing the supply chain, bug bounty programs, certification programs, all of these things are like programs that we have and processes that we have in place to ensure that we have kind of a broad kind of foundation across the ecosystem. And then moving up from that, really at the silicon level, the chip level, there's a number of innovations we're working with our silicon partners on. And we're we have our own Pluton security processor that we've licensed to silicon companies. But there's lots of interesting, technologies here to secure firmware and to ensure that the interface between the OS and the silicon itself is secure. TPM 2.0. There's all kinds of things we're doing in this space. And then going up the stack, of course, we have the operating system itself, the security we have in that, things like BitLocker, device health attestation, of course, all of our, Defender for IoT and Defender for Endpoint, and our update service itself that keeps the OS up to date with those security fixes. All of these things play a role. There's a lot of pieces here. I won't go through them all. And then, of course, going up the stack even more, there's application layer security. And then above that, you can have identity and privacy capabilities like biometric authentication, all kinds of access control and such. And then finally, all the way up in our cloud, a set of services that come from our cloud and that are used in the cloud. So it's really this whole cloud to edge security platform. And we think, we have a world-class solution here because we have everything from the operating system all the way up to the cloud, and we've been at this for a long time, and we feel really good about it. It's a constant challenge. The bad guys are always creative and working hard, so we never stop working as well. Now, kind of switching to the cost of the devices a little bit. These are things we've introduced over the last year or two, and we'll talk about what's coming next. But we've done a bunch of work with certain features to make the OS footprint smaller, so it can be used on devices with less RAM and less storage. So the target spec or the minimum spec for the device would be 2 gigabytes of RAM and 16 gigabytes of storage. And I've listed some of the features here, and there's a link you can see for more information on those. Now, what we're doing going forward is we're making it possible to remove more OS packages from the operating system in a way that is still going to ensure that when updates come down, those packages remain removed and there's no issues with updating. And so we're going to be publishing a blog post soon in the next month or two announcing the features and documenting the list of packages that can be removed and a script that shows you how to remove them. And so there's some icons here representing the types of things you can remove, like the printing package, for example, if you don't need that. And it's really about making the device not just smaller, but more manageable, lower the cost, potentially saving up to 300 megabytes of space. And so anyway, take a look when the blog post comes out, shortly. This might be something that's of interest to you. Now, this is a developer feature I want to jump into, which is around something we call the dual operator feature. And what this is, it allows a single Windows IoT device to have 2 displays, 2 sets of input devices, and 2 people interacting with one application that spans those 2 different displays with 2 different user experiences, but one application. So kind of the scenario might be, let's say a retail scenario. You have an employee, a retail clerk on the left in this diagram here, and then maybe you have a customer on the right side. They're both using their own displays. They have their own maybe keyboard or mouse or touch or pen input. But it's one application taking input from both people and displaying a different user experience to both people. And so this is available in the product today, but what we're doing is helping people understand how to use it. So coming soon in the June timeframe, we'll have sample code on GitHub. We'll document the architecture and the APIs you would use. There'll be a demo video, and there'll be a sample app. So a number of customers have asked us for this, so we're making it easier to use, and we think it's going to enable some really cool applications. So if you're a developer who wants to build something like this, stay tuned, and we'll make it easier for you to figure out how to do all this. Now, I want to talk about some of the new things that we're bringing out in preview, that are in preview right now. The first one is something we call, it's an internal name, Project Haven. It's not a brand name or anything like that, but it's about bringing Kubernetes to the embedded edge or the light edge, these OT edge devices. We'll jump into that shortly. I mentioned lower price devices. We're bringing the NXP i.MX 8 family of silicon to Windows IoT. That's in preview with a number of OEMs. Device Update Center is a way to help OEMs or operators manage updates and coordinate updates on devices. And then Edge Device Image Builder is really targeted at OEMs to making images that make it easier to make images for devices that are secure and Azure ready and properly configured. So let's jump into this a little bit. Project Haven. So really what this is it's a microservice platform for workload orchestration for these embedded devices on the OT edge. So what it is, it's a Microsoft-supported Kubernetes platform that is lightweight and is targeted specifically at these types of devices. So it doesn't require server-class networking or server-class storage, for example. You can install it on one node, one device, or multiple machines, clusters of machines. So as a developer, you'll be able to deploy it on your own dev box, without going through a lot of complexity of managing a cluster and configuring a cluster and setting up the networking and all of that. It runs Linux and Windows containers, and it will be managed via Azure Arc. So really what we're trying to do here is bring a common Kubernetes and Arc platform across the cloud, the heavy edge, the light edge / embedded edge, and having that consistent control plane across all of it. And even the tiny edge, which I won't go into here, there's a deep dive session on Project Haven in Build. I encourage you to see that. But even bringing those sensors and actuators into the fold, into the Kubernetes cluster, so to speak, without actually having to put code on those devices. There are some cool developments happening for really, really small, lightweight Kubernetes solutions on those devices. But we know there's literally hundreds of millions and billions of sensors out there today. How do you make those available as resources in the Kubernetes cluster? And we have a solution for that called AKRI, AKRI. It's an open source thing that anybody can participate in. Anyway, the deep dive session on Project Haven will cover that. So I'm just touching on it at a high level. I do want to address this briefly. People ask us what's the difference between EFLOW and Project Haven. They are both lightweight Mariner Linux-based VMs. So we're essentially evolving EFLOW with Kubernetes functionality. So we're bringing Kubernetes. We'll still keep the kind of the current EFLOW that supports just Linux containers with Azure IoT Edge capability, but we'll have essentially this new thing called Project Haven. That's not the real name, but whatever it ends up being, it's kind of taking EFLOW and evolving it into this new thing, which is this lightweight Kubernetes solution for the IoT and embedded edge. EFLOW is available today. Project Haven is still in preview. EFLOW, you only deploy it on a single machine, whereas Project Haven, it can be a single or a multi-machine cluster. They can both run, EFLOW runs Linux IoT Edge modules. Project Haven runs kind of generic Linux containers. Windows containers are supported in EFLOW until December 2022. We'll support Windows containers in Project Haven. The runtime APIs are probably the biggest difference. On EFLOW, it's IoT Edge, whereas Project Haven is Kubernetes interface. The data plane in EFLOW, it uses, there's an automatic connection to Azure IoT Hub, but with Project Haven, you can optionally use IoT Hub SDK to send your data up to Azure IoT Hub, which we expect a lot of customers to do. Control plane for EFLOW, you use the Azure IoT Edge portal, whereas Project Haven, it's Azure Arc or a local Kubernetes control plane if it's not connected to the cloud. Where you get your workloads from in EFLOW, you can get them from the Azure Module Marketplace or your own container registry. Of course, Project Haven, there's a Kubernetes ecosystem you can utilize. And pricing, EFLOW itself is free. Of course, you have to have an Azure subscription to take advantage of it, an Azure IoT subscription specifically. But you can kick the tires on it for free. And Project Haven, we don't know yet. We haven't, the product is not generally available yet, so we'll have to figure that out when we get there. So if this is Project Haven is interesting to you, there is a build session called Project Haven, Kubernetes for the Embedded Edge. I encourage you to watch that, and it will go into more detail. So just briefly touching on the NXP silicon, we're excited to be working with NXP on their i.MX 8 platform. We just announced the blog post of the public preview with OEM partners. The link to the blog I've put on the page here. We have a build session on this as well called Building the ARM64 Ecosystem on Windows IoT Enterprise with the i.MX 8 platform. So we're excited to have this coming to fruition, and stay tuned for more information. You'll start to see devices in market this year. And then I just want to touch on Device Update Center a bit. Device Update Center, as I mentioned, it gives solution operators and OEMs more control over updates on devices and allows them to coordinate a set of different updates together. So not just doing an operating system update or an application update or firmware and driver updates independently, because often those things have to work together. And even more importantly, in regulated scenarios like medical devices that are regulated by the FDA or maybe payment devices, the image that's on the device, inclusive of apps, OS, firmware, drivers, it has to be a certified image, has to be tested. And so increasingly it is becoming important to manage those updates as one unit and test them before they go to the device. So for instance, an OEM can use Device Update Center to kind of put a gate in front of the Windows update. So if there's an OS update, the OEM can say, don't send this to devices. I want to know about it. And then I'm going to, not only am I going to test that on my device, say, SKU number 27 as an example, I'm also going to test some application updates that I might have or some firmware updates that I got from the silicon partner. Test them all together as one unit. Okay, this works on SKU 27 of all my devices that are SKU 27. Now I'm going to release it, and then it gets pushed out to the customers as a single kind of group of things together. I think that covers it. As I mentioned, this is more of an OEM or perhaps a kind of a solution integrator operator type feature, and it is currently in preview. And then Edge Device Image Builder. This is definitely targeted at OEMs. And what it is we have lots of documentation for how to configure an image so that it's locked down. Like say you want to only allow this one app to run and it takes over the screen and there's no shell and these certain security settings are configured. There's a lot of steps to doing that. And so we've built a tool to do it. It's like a kind of a UI for configuring everything, and also enabling Azure cloud connectivity if that's something that customers want on that device. So enabling the security, the lockdown features, the Azure connectivity. So at the end of the day, you can press a button, generate an image that is secure and Azure ready. And so there is a deep dive session on this called Edge Device Image Builder. And there's a bunch of links here for where to get the bits or the documentation to try it out. So we're excited to have this get out there. If you've ever been out in the wild and seen a device, like say it's a digital sign, and it has like a pop-up on top of it that says, "Oh, an update's ready" or something like that. That's an example of a device, a Windows device that has not been configured properly. And normally that would get taken care of if it was put into this, the right configuration and using our kiosk type features. So just to summarize the additional sessions that are going on, there's a session on Windows IoT Security, and that they'll go much deeper into all these security features. I had that dense slide earlier. So there'll be a deep dive on that. The dual operator application feature, there's a deep dive on Project Haven for our Kubernetes and Arc work, Edge Device Image Builder, and then the ARM64 i.MX 8 session. So I encourage you to watch those if you get a chance. And I just want to thank everybody for attending today and watching this session. I really appreciate, all of our customers and partners who are here today watching this session, MVPs, and of course we always welcome feedback. So thanks again. I hope this was useful, and I hope you get a chance to attend more of the build sessions.